All right, so we're supposed to estimate the input values where the function has a relative extreme point. Then we're supposed to identify each relative extreme as a maximum or minimum and indicate whether the derivative of the function at that point is zero or does not exist. All right, well, if we look at this first one here, it's going up and it's going down and down. Okay, so if we take tangents, we have positives. Then at this point here, we've got zero, and then we're going down and have negative slope curve. Okay, so, well, it looks like at that point, x is equal to 3 is going to be what? A relative max. Okay, and that's going to be based on, it's changing from positive to negative. That's the horizontal slope. So that's going to be f prime of c is equal to 0. Okay. Now, what else? And why identify each of them and indicate whether the derivative of the function at that point is 0 or does not exist? Well, we just said that the derivative is 0, and that's because the tangent line is horizontal. Okay. So because of that, we have everything here. Now let's look at the next one here. The next one we have what? Well, it looks like maybe about right there, which appears to be here. It looks like at x equals 1, we have a relative max. Okay. And what happens there? Well, it looks like we're going to have, again, a derivative is equal to 0 is 0. So our tangent line is horizontal. Okay. Now, do we have anything else? No, that's not going to be the minimum. That's not going to be a minimum. There's nothing else here that we can get. That's an endpoint, so that's not going to be a max. And so that's the only thing we can get here that's possible. All right, what about this one? Well, here we've got a bump up and then a point down and then a bump up again. So if we look here, we'll have a tangent line there, we'll have a tangent line there. So looks like at x equals 1 and x equals 4, we have relative maxes. Okay. Now we have a minimum here. Okay, that could be a relative minimum. And so that's at what? X equals 3, it looks like. So that looks like a relative min. Now, what can we say about the derivative? Well, the derivative here and here is 0, okay, because we have those horizontal tangent lines. So I'm not going to write all that here. But here, what's the derivative? Well, the derivative does not exist because at a point we don't have a derivative, and so it doesn't exist at that one there. So this one's a little different than these here because, the only places we had the relative maxes in this case were horizontal uh, lines for the tangent. Now here, we do have a relative min, but it's not going to have an existing derivative. So that's going to be a key on points. Sometimes maybe this would be a filled in circle, and so then that would be a relative min as well. But then again, we're not going to have a derivative existing if that was filled in. Okay. All right, so now we're supposed to sketch a graph of a function whose derivative is 0 at x equals 3, but that has neither a relative maximum nor a relative minimum at x equals 3. All right, well, I think I could have, if we think about this, if we're going to have it x equals 3, now probably I'm going to draw that in later. We could come up here and remember if we have something that looks like this, we're going to have horizontal, is equal to 0. And so that would give us what we need. The derivative is 0 at x equals 3. So maybe it's going to come up like that and then like that. And let's call this point R3. That would give us a horizontal, the tangent line. So the derivative is 0 x equals 3. But there's no max or min at that point. Now another one we could just do a horizontal line. And if we call that 3 again, you know, that's going to give us tangent. It's going to be through that. So it's going to be what it would be. But either one of those would work. I think I would first come up with this one. Then if I thought about it a little longer, I might come up with that one. But, this is be probably the key one I would come up with because, I would know that horizontal is tangent there, but there's not going to be a max or a min. All right, so let's pause there and then come back for some more.